All right, the next section we're going to be looking at is solving different quadratics by factoring. So some of these will be easier than others, but I just wanted to give you kind of a healthy mix, just so you are ready for anything you might see when you actually take the test. So this first one, so one big idea is if you're factoring a trinomial, if A is 1, you don't need to group. I mean, you can, you'd get the right answer, but you're doing more than you need to. If your A doesn't equal 1, you need to group. Unless you can like factor it out as the GCF and make the A1, you're kind of screwed. Sorry about that. So some of these will be easier. I kind of made these probably progressively get a little bit trickier. But this first one, I mean, you don't have to write the X. I mean, if it helps, please do. But what multiplies to 8 adds up to -9? We've been seeing a lot on this sheet so far, but it's 8 and 1. Both of these would be negative, though. We've seen a lot of questions so far. I feel like that it's been 1 in itself. Don't forget to check that one. Once you get it in factored form, just solve this, or really what you're doing is you're setting each one of these binomials equal to 0. So like x minus 8 equals 0, but that would just be positive 8. And then you're setting x minus 1 equal to 0, you would get positive 1. This next one is, I think, deceivingly easy looking because it is, but I mean, if you can't think of how to do it, it's going to mess you up. But just remember, if you see any of these problems, you should always think about, can you pull out a GCF? Because usually that makes it easier. But this is a question where you actually need to pull out the GCF to really be able to factor it. So our GCF for this one, we could pull out a 5. But don't forget about the variables. If both parts have x's, you should be able to pull out at least an x, or you might even be able to pull out an x squared if your powers are high enough. You know what I mean? It just kind of depends what you have. But if you pull out a 5x, we would just have x and then 3. And if you double check, like if I distribute, I get back to where I started. And really what we're doing, whatever you pull out, you're dividing these parts by it. So like 5 divided by 5 is 1. X squared divided by x is just x. You basically cross one out. Same idea with the next one. The x's cancel. 15 divided by 5 is 3. But once you got here, you just got to set each part equal to 0. So 5x equals 0 would just be 0. I mean, I know that might seem weird, but just I'll erase this in a sec. But you'd have 5x equals 0. Any 0 divided by anything is still 0. Oops, I need to erase all that. So x equals 0, and then x plus 3, just set it equal to 0, you would get -3. This next one, you could either do grouping, but this is why you always want to be looking for a GCF, because you could factor out a 2. Like all 3 parts are divisible by 2. I mean, if you get decimals, you probably don't want to factor it out. I mean, it's possible, but decimals make it difficult to think things through. But now we want to see, can we factor what we have on the inside? Does anything multiply to 64, add up to -16? That would be -8 and -8. So you could either write it twice, or you could even put x minus 8 squared. Doesn't really matter. You're just going to get one answer. I mean, you technically get the same answer twice. So, I mean, you could write it twice, but usually you don't really need to repeat yourself. So, I mean, if you wrote it twice, no worries. If you write it once, you don't have to. So if you get the same answer, I mean, you really just have to write it one time. But that's not super common. So, but if not, if you didn't see you could factor out that 2, you would have to do grouping because your A is not 1. And that's a lot more work. So that's why it's worth seeing, can you pull out a GCF? Because grouping, at least in my opinion, grouping is probably my least favorite topic on this test. I usually do anything I can to avoid grouping. I mean, it's a good thing to know, but honestly, it's my least favorite. So this last one is one where we have to do grouping. I can't like factor out the 7 because I get a bunch of decimals, which wouldn't really make my life any easier, unfortunately. So to do this, just remember you're going to do A times C. So 7 times -6 would be -42. On the bottom, just put your B. So same thing, we're trying to find something that multiplies a negative 42, adds up to negative 19. Sometimes it can take you a bit. It's one thing why grouping can be tough too, is sometimes you get bigger numbers or you just don't see it, but it would be 21 and 2. I wrote the wrong sign though. You'd want positive 2 and negative 21. That would add up to negative 19. So grouping's where you have to rewrite this middle part. So you keep the x squared part, but you break up the 19x, the minus 19x into what we got. So we'd have minus 21x plus 2x minus 6. Line down. So we group up the first two parts and we group up our second two parts. So the GCF, at least in the order I have here, I can pull out a 7 and an x. You always will be able to pull out an x of your first group. So if I pull that out, I have x minus 3. So we're trying to pull out our GCF of the second group. That also gives me x minus 3. That would be a 2, a positive 2. Now that we've got it, we'll put our GCFs together and copy one of our x minus 3s. And now that it's in factored form, find your answers. Like this would just be x equals positive 3. You could set up an equation for this and solve. Like I recommend, if you can, just do it in your head. Like if you're solving 7x plus 2 equals 0, you're going to subtract 2, which is going to give you negative 2. Divided by 7, that's going to give you negative 2 over 7. Sorry, it's not letting me write that, but I'll just write it up here. It'd be negative 2 over 7. Okay, so that's definitely a bunch of factoring. Like I said, I probably won't see every single one of these types, but if you can do all 4 of these, you won't see anything that you can't handle.